Dear learners, welcome to the another new lecture of Engineering Chemistry e-lecture series. In today's video, we will discuss the zeolite process in detail. The topics to be covered in today's video included the basic principle of zeolite process, methodology of zeolite process, the chemical reaction involved in removal of the hardness by zeolite, regeneration of zeolite, advantages and disadvantages of zeolite process, and the numerical problems based on the zeolite process. So let us begin with the basic principle involved. So first of all, we must know what is the zeolite is. So zeolites are the group of several microporous crystalline aluminosilicate minerals commonly used as commercial adsorbent and the catalyst. So basically zeolite are the group of minerals which involves two types of the minerals, that is the silica and the alumina, which also incorporated some metal ions. They mainly consist of the silicon, aluminium, oxygen, and have the general formula M n plus 1 by n AlO2 SiO2 X dot YH2O. This is the general formula of the zeolite category of minerals, where this M stands for the metal like magnesium, sodium, potassium, lithium, calcium, or it may be the H plus ions. The basic structure or the general structure of the natural zeolite is shown in this figure. Here we can see that it is having the case-like structure in which the alumina and silica tetrahedron cages are there, and in between these cages the metal ions are captured. These metal ions may be magnesium ions, calcium ions, sodium ions, lithium ions, etc. So this is the basic general structure of the zeolite type of compounds. Now question comes to our mind that which type of zeolite is used for the water softening process. So the answer is here. For water softening process, the sodium zeolite is used, and the sodium zeolite is the sodium aluminium orthosilicate with the formula Na2Al2Si2O8 dot XH2O. So this is the formula of sodium zeolite which is used for the water softening process. It is commonly represented as NaZe, where Ze stands for the Al2Si2O8XH2O. So basically this all unit will be represented by the Ze, and it is associated or joined with the sodium ions. So the representation of sodium zeolite is NaZe or Na2Ze. This sodium zeolite occurs naturally, or it can be manufactured synthetically also. The main thing is that the case-like structure of zeolite make it very useful for the exchange of ions. That is why it is used for the water softening process, because it can easily exchange its sodium ions with the calcium and magnesium ions. So the use of it is also called as the permutate. So the use of permutate as softener is based on the fact that it exchanges its sodium ions very easily with the other heavy metal ions such as calcium and the magnesium ions present in the water. So since it can easily replaces its sodium ions with the calcium or magnesium ions present in the hard water, so that it can be used for water softening process easily. Here we can easily see that when it reacts with the calcium or magnesium salts, the sodium ions get replaced by the calcium or the magnesium ions. So now the sodium zeolite is changed into the calcium zeolite or the magnesium zeolite form. So this is the basic fact that why sodium zeolite can be used for the water softening process. Now the second point is the methodology of zeolite process. So to make the water soft, the zeolite softener is used. In this zeolite softener, the zeolite, we have the steel tank which is packed with the thick layer of the zeolite or the permutate. So in this steel tank, all these here is the zeolite bed is fixed. What is zeolite bed? It is the sodium zeolite. So and the from upper part there is an inlet for the raw water, and at the bottom there is outlet for the soft water. So when we pass the hard water, which is the raw water, from the zeolite or the permutate, the hard water containing calcium or magnesium salt, when percolated through the zeolite bed, it exchanges its calcium and magnesium ions with the sodium ions of the zeolite, and at the bottom of the tank, when water collected, it contains sodium and sodium salts rather than the calcium or magnesium salt. So this water is the soft water which can be drained out from the outlet of this tank. So this is the basic principle or basic method for the softening of the water. So when hard water percolated through this permutate or the zeolite, the calcium and magnesium salts present in the hard water are removed by the zeolite as it exchanges its sodium ion with the calcium and magnesium ions, and the resulting soft water can be collected from the outlet of this tank. Now the chemical reaction involved in removal of the hardness by zeolite process. It can remove temporary as well as the permanent hardness. We know the temporary hardness is due to the presence of bicarbonates of calcium and the magnesium ions. So when hard water containing the temporary hardness pass through the sodium zeolite, the calcium and magnesium ions of the bicarbonate salts are trapped with the zeolite, and now this sodium zeolite is changed as the calcium zeolite or the magnesium zeolite, and in the water the sodium bicarbonates are present in place of the calcium and magnesium bicarbonate. So we can say the temporary hardness is removed by the sodium zeolite very easily. Now removal of the permanent hardness. We know the permanent hardness is due to the various other salts of calcium and magnesium like calcium chloride, magnesium chloride, calcium magnesium sulfates and nitrates, etc. So when these salt containing water pass through the sodium zeolite, all the calcium and magnesium ions get exchanged with the sodium ions present in the sodium zeolite. Now the zeolite is changed in the calcium and magnesium ions, and the water which is passed through the zeolite now containing the sodium salts only. So no calcium, no magnesium salts are remaining in the water. It contains only the sodium salts, and all the calcium and magnesium ions are now trapped with the zeolite. So these are the chemical reaction involved for the removal of the temporary as well as the permanent hardness for removal. Now in this reaction we can easily see that when the zeolite is used for the water softening process, after some time it completely changed into the calcium and magnesium zeolite form. So now if all the zeolite bed now converted into the calcium and magnesium zeolite, so further removal of hardness is not possible. So this how this problem can be resolved? This problem can be resolved by the regeneration of the zeolite. So what is the regeneration? Basically, the activation of exhausted zeolite or permutate is called the regeneration. What is the meaning of the exhausted permutate or exhausted zeolite here? That means the zeolite which is now converted into the calcium or magnesium form is called as the exhausted zeolite, because originally what is the form of the sodium zeolite? It is originally the sodium zeolite form which is used for the water softening process, but now during the softening process this sodium zeolite converted into the calcium or magnesium zeolite. So these calcium and magnesium zeolites are the exhausted zeolite. The activation of these exhausted zeolite is called the regeneration. So by the regeneration process, we can again convert the calcium or magnesium zeolite into the sodium zeolite form. In general, the zeolite bed or the permutate bed can work about 12 hours. After that, it is completely converted into the calcium and magnesium zeolite form. So it ceases to soften the water. So we have to regenerate after 12 hours the exhausted zeolite. So how the regeneration process can be done? It can be made active. That means zeolite can be made active by passing the 10% solution of the sodium chloride. When we pass 10% sodium chloride from the regeneration tank from here, so after 12 hours what we do? We stop the raw water supply from here, right, and start the supply of concentrated 10% NaCl solution from here. So now the NaCl solution is passed through the exhausted zeolite, and this NaCl solution, since it is in the concentrated form, so now the concentration of sodium is much higher than the calcium and magnesium. So it can easily change the calcium ions with the sodium ions. So the exhausted zeolite, that is calcium zeolite, now reacts with the 10% solution of sodium chloride and it converted into its original form. That means it is regenerated again in the sodium zeolite form, and from drain we can drain out the calcium and magnesium chloride. So from where is the drain? When we stop supply from the hard water and start the supply of the sodium chloride here. So when we start the sodium chloride supply here, the coming out solution is the calcium and the magnesium solution, calcium chloride and magnesium chloride, which can be drained from this outlet here. So now in this way we can regenerate the exhausted zeolite into its original form. Now coming towards the various advantages of zeolite process, as we seen by the reactions that this method can completely remove the calcium and magnesium ions. Therefore, this method can produce the water having zero hardness. The softening plant occupies a small area. The plant or the zeolite softener is very small area, very small. That is why it occupies small area. This method is very cheap because the regenerated permutate is again used and the process can be repeated a number of times, and the consumption being only the NaCl consumption, which is very cheap, almost inexpensive. So this method is very cost effective method. No sludge is formed and hence there is no problem of sludge disposal. While in lime soda process we have seen that there is the large quantity of sludge is formed, which causes the problem of the sludge disposal. But in this method no sludge is formed, therefore sludge disposal problem cannot occur. Next is this process can be easily made automatic and continuous, which make it more effective. The process automatically adjusts itself for different hardness of the incoming water. So these are the some advantages of the zeolite process. Coming towards the disadvantages of zeolite process, this process is not useful in case of the turbid water because the suspended impurities present in the turbid water will clog the pores of zeolite bed and these restrict the flow of water. So if water having the turbidity, so we must remove the turbidity before passing this water into the zeolite softener. Second disadvantage is this zeolite system can work best around the pH 7. If water contains mineral acids, it must be neutralized with the soda before passing to the zeolite bed because these acids can destroy the zeolite. So this method works best around the pH 7, that is at the neutral pH. Next disadvantage is the water containing large amount of colored ions like manganese and iron ions when passed through zeolite bed are converted into the iron zeolite and the manganese zeolite, which cannot be regenerated easily. So if the water containing manganese or iron ions, this water can completely exhaust the zeolite because these ions, when exchanged with the sodium zeolite, sodium ions, these are permanently stick to the zeolite which cannot be regenerated again. So if the water containing manganese and iron ions, the zeolite can completely wasted during this softening. Next disadvantage is lead cannot be removed by this method because lead cannot be exchanged with sodium ions in this zeolite. And next is the zeolite can exchange cations like calcium and magnesium ions, but all the anions remains in the soft water because the zeolite exchanges only the cation, calcium and magnesium ion replaces with the sodium ions, but all the anions remaining with this solution or the softened water. Thus, the soft water containing large amount of anions like bicarbonate, carbonate, hydroxyl and sulfate ions, which causes many type of problems in the industrial water or in the boilers. For example, this process leaves the sodium bicarbonate in water, which may cause various type of boiler troubles such as caustic embrittlement, boiler corrosion, priming and foaming. So the main disadvantage of this process is that it only removes the cations. All the remaining anions like chloride, sulfate, carbonate, bicarbonate, hydroxyl remains in the soft water itself. And when this soft water is used in the boilers, it may create many type of boiler troubles. So these are the disadvantages of the zeolite process. Now let us discuss the numerical problem based on the zeolite process. So the hardness of 1000 liter of water was completely removed by zeolite softener, right? The zeolite bed requires 30 liter of NaCl solution containing 150 gram per liter of NaCl for regeneration. Calculate its hardness of water sample. So before going to detail in this numerical problem, just revise the basic concept of this zeolite process. See here, the raw water containing calcium and magnesium salts can be made softened by using sodium zeolite. So all the calcium and magnesium ions present in the hard water are now remains in the zeolite bed during the softening process, and for this exhausted zeolite we use sodium chloride for its regeneration. That means the total sodium chloride used must be equal to the total number of calcium and magnesium ions or the hardness present in the zeolite bed. So the amount of sodium chloride used for regeneration, this sodium chloride used for regeneration must be equal to the hardness present in the water, because this sodium chloride is used for the regeneration of the exhausted zeolite. So total amount of sodium chloride used must be equal to the total calcium and magnesium ions or the total hardness present in the water, right? So using this fact, now calculate the total hardness of water. In the question it is given that 1000 liter of hot water is equal to 30 liter of NaCl solution. Read the numerical again. The hardness of 1000 liter water was completely removed by zeolite softener, and this zeolite softener requires 30 liters of NaCl. So 1000 liter of hard water requires 30 liter of NaCl for regeneration. Right? So this 1000 liter of hard water must be equal to 30 liter of NaCl solution, and the concentration of NaCl solution is 150 gram per liter. That means 1 liter of NaCl contains 150 gram of NaCl. So 30 liters of NaCl contains how much amount of sodium chloride? That is 30 multiplied by 150. So that is 4500 gram of NaCl. So we can say that 1000 liter of hard water is equal to 4500 gram of NaCl. Now we know that hardness is expressed in terms of the calcium carbonate equivalent, and calcium carbonate equivalent of any salt can be calculated by multiplication factor multiplied by amount of that salt. And what is the multiplication factor? Multiplication factor is the 100 divided by the molecular weight of that salt. So here the multiplication factor of sodium chloride is 100 divided by 117. This is the multiplication factor of NaCl. So calcium carbonate equivalent of NaCl is equal to 100 by 117 multiplied by 4500 gram. So this is the 3846.15 gram of calcium carbonate equivalents. So now these calcium carbonate equivalents is equal to 1000 liter of water, or present in the 1000 liter of water. So we know from equation number 1, 1000 liter of water is equal to 4500 gram of sodium chloride, and from equation number 2, 4500 gram of sodium chloride is equal to 3846.15 gram of calcium carbonate equivalent. So from equation number 1 and 2 we can say that 1000 liter of water is equal to 3846.15 gram equivalent of calcium carbonate. If 1000 liter of water is equal to this much amount of CaCO3 equivalent, so 1 liter of water is equal to 3846.15 divided by 1000. So this is the 3.846 gram of CaCO3 equivalent. We know that hardness is present in milligram per liter. So we have to convert this gram into milligram. So this is the 0.3846 milligram calcium carbonate equivalent in 1 liter of water. So the hardness of this water sample is 0.3846 ppm. Again, let us rewind it. The hard water sample volume is 1000 liter. When this 1000 liter of water made softened by using the zeolite softener, and the zeolite softener for regeneration requires 30 liter of NaCl. That means 1000 liter of water is equal to 30 liter of NaCl. 1 liter of NaCl contains 150 gram of NaCl per liter. So 30 liter of NaCl contains 4500 gram of NaCl. So that must be equal to 1000 liter of hard water. Now this amount of NaCl must be converted into CaCO3 equivalent, because the hardness is always expressed in terms of the CaCO3 equivalent. So for the conversion of CaCO3 equivalent, we have to multiply the amount of NaCl with the multiplication factor. So this is the calcium carbonate equivalent of the sodium chloride. Now convert this calcium carbonate equivalent into the milligram, results in the hardness in ppm. So this is the total hardness of the given water sample in the ppm. So in today's video we covered the zeolite process, including the basics of the zeolite process, the chemical reaction involved in the zeolite process, methodology of zeolite process, advantages and disadvantages of zeolite process, and the numerical problem based on the zeolite process. So that's all for the today's video. Thank you so much. To unlock more awesome content, you can hit the like button and subscribe my channel. Once again, thank you.